All right, a couple of ways to do this problem. The question is, this is number 26, all right? Which equation best represents this graph? All right, so you look at the graph, and then you look at the answer choices. And if we look in on the answer choices, we see there's an exponential curve, because the variable is in the exponent position. That's A. B is a radical function, because the x is underneath the square root symbol, so that's a square root, a radical function. C is a log function, right, because it's got log in it. And D is another radical function, because the exponent is in the radical position again. Okay, so part of what they're asking you to do really is look at, now, I mean, easy way to solve this, easiest way would be to go to Desmos, go to your calculator, and graph all four of these functions, and then see which one looks like that. And I can tell you that based on looking at this, there's only one that's going to even come close to looking like this function. So that's an easy way to do it. But, I'm here to do math, so I'll tell you how the math works too. Well, what I can tell you is that this curve here, this type of curve, is an exponential function. This is an exponential curve. It's called an exponential decay function because instead of going up like exponential growth, it actually goes down. It's getting smaller and smaller as we go along. How can we tell which one? So if we think of it that way, we know it's not B, we know it's not C. The difference between A and B, and I think I want you to see the key difference here, is that in A, the number that has the exponent on it is less than 1, right? So this is some less than 1 number, 1/5 is less than 1, to the x power. In D, we have a number that's greater than 1, that's the base of the exponent. So we got 5 to the x power. If you remember, and you're not necessarily going to remember this, but if you remember, exponential growth functions, that are the ones that look like this, get bigger over time, always have a number that's bigger than 1 as the base of the exponent. Exponential decay functions look like that. They always have a number that's less than 1, but greater than 0. That is the base of the exponent. So on the basis of that, we can figure out that it's A. But if you've forgotten that, and I wouldn't be surprised if you did, one thing to look at is just plug in a number. And the easiest number in general to plug in is going to be 0. Well, if we had A, right, f of 0 would be 3 times 1/5 to the 0 power. Well, 1/5 to the 0 is just 1. Anything to the 0 power is 1. That's why I chose 1. 3 times 1 is 3. So we would get, there's a point on A, 0, 3. If I look at D, f of 0 would be 1/3 times 5 to the 0 power. Well, 5 to the 0 power, again, is 1. Anything to the 0 power is 1. So f of 0 would end up being 1/3. So we get a point 0, 1/3. If I look at this curve up here, I can see there is a point 0, 3. There is no point 0, 1/3. So it couldn't be D, and it has to be A.